Hello everyone. In our video today, we're going to be looking at how to calculate the last value that can be substituted in the general term. So if you look at our question, it says determine M. Now if you look at M is the last value that can be substituted in a general term when you're given a sigma notation. Now we've already done a video on sigma notations. If you haven't seen that video, I would recommend that you first start by watching that video before you actually get to this example. So basically here we're not calculating the sum is given. In other words, we are told that Sn, the sum of the following series, remember this is a series, so the sum of the following series starting from k, it's 2 up until m, is actually going to be given by 24, 1/5. Now, in our previous video, I said if we want to deal with sigma notations, we can try to use the following 4 steps. First thing that we can do is to calculate the number of terms in this series. So how do you calculate the number of terms? It's our n. N can be given by top minus bottom minus the 1. So what is written at the top, if you can see here clearly, it's m. So we're actually going to say that it's m minus what's written at the bottom. You can clearly see it's a 2, so it's going to be 2 plus a 1. Now m minus 2 plus a 1, it says that instead of n, we can write it as m minus a 1. So instead of Sn, we can say it's S of m minus a 1. So instead of saying Sn, we can say this is equaling to Sn m minus a 1. So instead of n, we can put m minus a 1. You can clearly see here, instead of n, I decided to put m minus a 1 because it's exactly the same thing. Now, I already told you our Sn is given, which means S of m minus a 1 is also given, which is 24, 1/5 as a mixed fraction. Now, we can say this is our first step, getting the number of terms. Now, as our second step, I said we need to expand the series. The first value that we can substitute on the series, they say it's a 2, so it means here I'm actually going to have 1/15, and then it says instead of k here, I remove the k, I put a 1, so I have 3 to the power of 2 minus the 1. If I type that in my calculator, it gives me 0,2 plus. Next, instead of 2 now, the next value after 2 actually going to be a 3. Put a 3. If I put a 3, it gives me 0,6. Do that, I also put a 4. If I put a 4, it gives me 1,8 plus. Now, I also have to get the last value. How do I get the last term? By substituting the last value, which is m. So now, instead of 3, I'm actually going to put m. So if I put m, it says it's going to be 3 to the power of m minus a 1. So my last term is actually going to be given by 1/15, and then it says multiplied by 3 to the power of m minus 1. So that's my last term. Now I need to check, so we'll call this one our step 2. So our step 2, expand and get our series. Now we go to the next step. The next step is to check what kind of a series it is. So if we do this, first check if it can be arithmetic. We say 0,6 minus 0,2 gives us 0,4. 1,8 minus 0,6 gives me 1,2. Clearly it's not arithmetic. Now if it's not arithmetic, I can try to check if it's a geometric by saying 0,6 divided by 0,2 gives me a 3. Say 1,8 divided by 0,6, it also gives me a 3, so it's clearly a geometric. So I've decided what kind of a series. I go to my next step to choose the correct formula. That's step number 3. So I'm actually going to say that it's Sn is actually going to be a r to the power of n minus a 1 all over r minus 1. Now I know what is Sm. Sm can be written as S of m minus 1, meaning everywhere I see n, I can put m minus 1. So my first term, if we look at it, says it's 0, 2. So here I'm going to put 0, 2, open bracket, and then it says r. Now here, so that you can see, instead of n, I can put m minus 1. All over 3 minus 1. Now remember, we know what is our r. So instead of r there, we can put 3. Now the first thing that I can do is to subtract the denominator. I have 3 minus 1, and at the same time I also know what is S of m minus 1. If you check here, I said S of m minus 1 can be given as 24 1 all over 5. So to make matters simple, instead of writing S of m minus 1 here, I'm simply going to write this as 24 1 all over 5, which is a mixed fraction. Now our calculators do have mixed fractions, so straightforward. So we are actually going to have 3 minus 1, which is a 2, so I will multiply by 2 both sides. Now if I multiply by 2 both sides, it says these 2 and the 2 in the denominator are going to divide each other. And this side I'm actually going to have 24.2, which is actually going to be 0, 2, open bracket. It says it's 3 to the power of m minus 1 minus 1, close bracket. Next thing will be to divide by 0, 2. Even this side divide by 0, 2. Now if you divide by 0, 2 both sides, you get 242, which is actually going to be 3 to the power of m minus 1 minus 1. Going to take this one to the other side, it gives me 243, 3 power m minus 1. Now since we are dealing with exponents, we're going to change this one, and then it's going to give us as a prime product 3 to the power of 5, which is going to be 3 to the power of m minus 1. Now bases are equal, then the exponents are equal. It says m should be a 6. So the last term, the last value that we can substitute to get our last term, is actually going to be a 6. Now that's it for our lesson today. We have the following activity to check if we understood.